Okay, so for this question 15, they mentioned that a radioactive sample of the sodium thiosulfate, which of course gives our S2O3 2-, okay, it is prepared by boiling solid sulfur containing sulfur with 35 mass number. Of course, if you compare it to the periodic table sulfur, it is 32. So it just means that this 35 sulfur is just a isotope, okay, of 32 sulfur. And in this case, it is boiled with sodium sulfite. So of course, you need to know your sulfite is SO3 2-, and since it gives the mass number here, you know it is 32. Okay, and they add this HCl to the sample, causes all the 35 sulfur to precipitate as sulfur, leaving a resulting solution that contains non-radioactive sulfite ions. And of course, this sulfite ion refers to 32. Okay, since non-radioactive is for the isotope sulfur 32, it just means that sulfur 35 is radioactive. That is how they actually make a sample that is radioactive, okay? Because your S35 plus your SO3 2- 32, you get S32 O3 2- with S35. So with the 35 here, of course, it will give us our radioactive thiosulfate. Okay, so the question asks, which of the following depicts the correct displayed formula of the thiosulfate produced? So for this question, I think that most of you will actually start to draw S2O3 2- by doing 6, 6, and then 6, 6, 6, and then the 2- is given to O, which is the more electronegative atom, and so in this case plus 1, so you should get 7, 7, so 6, 7, 7. Well, there's nothing wrong in doing this if they ask you to draw S2O3 2- just like that. But in this case, the question actually tells you that you actually make this from sulfur and SO3 2-. So you actually need to draw the Lewis diagram for both of these separately and add it up to give your S2O3. This is simply just like our examples of I3- and the previous HF2-. Okay, you draw two things separately and then join them together through a dative bond. But of course, what is special about HF2- is that because H cannot take more than 2 electrons, you have to change the dative bond to a hydrogen bond. But otherwise, usually in this type of cases, you need to draw a dative bond. Okay, so I'll erase these two examples. We will apply this concept to S2O3 2-. So sulfur, we know that it is from group 6, so it should have 6 valence electrons in the atom. 1, 2, 3, 4, 5, 6. And we know that it is sulfur 35. For SO3 2-, we know sulfur is from group 6, oxygen is from 6, 6, 6. But we know with the 2- it should become 6, 7, 7. Okay, and we know that 6 over here should give a double bond. The 7, 7 over here should give a single bond. Okay, so let's draw SO3 2- together. So let's put sulfur as the central atom because it is less electronegative. So double bond with oxygen. So I should draw something like this. And the oxygen is left with 2 more lone pairs. Okay, and for the single bonds, of course, single bond with 1 oxygen and 1, 2, 3, 4, 5, 6. With another oxygen, I will have 6 electrons left over. And for the sulfur central atom, I used up 4 electrons in the bonding, so of course I have 2 more electrons left over. And then of course remember to put the bracket with the 2 minus sign. So in this case, similar to the examples of the I3 minus, okay, this lone pair will be donated to the central sulfur atom through a dative bond. Okay, through a dative bond. So how do we draw it? So I just simply need to add on to the existing diagram. I just put a sulfur here with a dative bond. So that means I need to draw 2 electrons to form the bond. Okay, and I will have 1 lone pair and 2 lone pair left over. Alright, so from this dot cross diagram, I can easily convert it to a Lewis diagram. So with a sulfur, okay, double bond, oxygen, left with 1, 2, 3, 4 electrons. Single bond to this O, 1, 2, 3, 4, 5, 6. Single bond to another O, 1, 2, 3, 4, 5, 6. And lone pair left over, okay, with a dative bond with the sulfur. So 1, 2, 3, 4. And overall, please remember to put the square bracket and the charge. So this should be my answer. And of course, not forgetting the central sulfur atom is 32 and the terminal sulfur atom is the 35. Okay, but if you look at your answer, you actually don't find this in your answer, whereby you have a dative bond from the sulfur, terminal sulfur to the central sulfur. So if you check, it is actually the central sulfur to the terminal sulfur. So why is that the case? Well, very simple. Just need to take a look at this terminal sulfur. Count the number of electrons surrounding it. Actually, it is just 2, 4, 6 electrons. Well, it is short of octet. It is short of octet configuration. So of course, instead of the terminal giving to the central, and so I have to change the direction of my dative bond from the central sulfur atom to the terminal sulfur atom, okay, and I would have to remove this 2, okay, place it back on the terminal sulfur atom and use up these 2 lone pairs, okay, and dative bond to my terminal sulfur atom. Okay, and of course for my Lewis diagram, I would have to change the direction. Okay, and so this will be my correct answer. So your correct answer should be D. Okay, then I think at this point in time you would ask, so I have to spend so much time on just a single MCQ question? Well, the answer is actually no, because what I've went through is simply just the complete thinking process to get this answer. But during your MCQ question, you just need to know one concept. So based on this concept, you can complete your MCQ in less than 1.5 minutes, which is the standard for one question. So the concept is very simple. Okay, there must be a dative bond from sulfur to sulfur. Okay, so just based on this concept, straight away cancel out A as your answer because there's no dative bond at all, and you can also cancel out option B because it is a dative bond from O to sulfur, which is not correct. And for option C, the only difference in this case is 35, 32 and 32, 35 sulfur. So of course, based on this, you know that the terminal sulfur must be the 35. Okay, based on the fact that the question gave you 35 sulfur. Okay, so the answer should be D.